To my presentation on a gradual release model for teaching AP Computer Science A. My name is Jem Yeshiliurt, and I participated in the AP Summer Institute training program um, in summer of 2022. And this presentation is basically about how to structure a lesson in Computer Science A. I was an attendee, I'm a teacher, I'm not representing AP or anyone else other than myself. And yeah, let's just get right to it. So here's some information about me. I'm a math and computer science teacher at Pioneer High School in San Jose, California. I have a background in civil engineering. I've had coding experience since 2010, and I worked as a researcher and private teacher for more than 5 years. And I'm currently entering my third year of teaching at a high school, so this will actually be my first year teaching AP Computer Science A. So here's just a quick introduction. Um, you know, a lot of new AP computer science teachers are wondering probably, how can I structure my day-to-day lessons and how can I help students really retain the information that I teach them? So in this presentation, I'm going to propose to you a model that I'm planning to follow and try as a first year AP computer science A teacher this coming year. So here are some terms that I'll be using. Cognitive load is the amount of mental effort that a person exerts to complete a task. And scaffolding is basically the set of instructional supports that a teacher uses to make content more accessible for students. So that includes visual representations, outlines of code that need to be filled in, things like that. And what a gradual release of responsibility is the process of a teacher bearing most of the cognitive load at the start of the lesson and then using scaffolds to gradually transfer that load to students until the students are able to bear the load all on their own and successfully complete tasks that apply the concepts that were taught in the lesson. So here's a possible daily lesson outline for a 55-minute period. There's a start of class routine, which is 5 minutes long, a modeling section where I do most of the work, and that's between 10 and 15 minutes. Then there's a progress check where the students and I do together the work. That's 5 to 10 minutes long, and that's formative assessment primarily. Then there's a guided practice section where the students work on things together for about 10 minutes. And then there's an independent practice section where students work on an assignment individually. And then finally, at the end of class, there's a closing routine which takes 5 minutes. At the start of class, I assign a quick warm-up problem so that where students work together in partners or teams. Activating prior knowledge really will help them learn and help them connect previous concepts to what we're learning today. Some possible activities include code tracing, error analysis, predicting and comparing results, looking for a pattern, and think pair shares. And I got these from the AP course and exam description. I can get the quick warm-up problem from the AP Classroom problem bank or some other source. And I would recommend using the publicly available questions so that the secure ones are kept secure. After giving them a problem that they can solve in maybe 1 or 2 minutes, maybe 2 minutes, I would call on a pair of them or a team to explain their answer and then give them feedback. This will increase their accountability and sense of accountability and participation. Finally, I would explicitly state the learning objective, what we will be learning that day, so that the students get oriented to that. And then that's a good segue to the modeling section. So in the modeling section, I'm going to give a PowerPoint presentation on the concepts for the day. This is to introduce students to the topic and methods used in the lesson. I'm just going to have a few small examples to illustrate concepts. Quick examples are good enough, and I can get some of these questions from the problem bank or online. I'm going to limit the modeling to 10 to 15 minutes, ideally 10 minutes, because students have a hard time focusing for longer than that. After the modeling section is a progress check, where I ask 2 to 3 formative assessment questions to the students. Students discuss those in pairs or teams, and this helps them learn through social interaction. Then I call on the students to share or explain their work. Either they come up to the board or respond to me verbally from their seats. Then I provide feedback so that they can correct any common errors and self-assess to see where they are. After the progress check is the guided practice. This is where I introduce a longer example, like a coding exercise. This kind of in-depth look at coding as through a live demonstration will help them develop their skills. I plan to use a class coding platform that allows me to display student work. Two options that came up in the training that I'm willing to explore are Coding Rooms and Repl.it. Coding Rooms is a web-based service that lets teachers see, display, and edit their students' code in real time. There is a free option to use it. Repl.it lets a teacher see and display student code after it's submitted as an assignment, and that's also free. Repl.it may add real-time capabilities, or maybe it has already added and I'm not aware, but these are two options that I plan to look into. I plan to give students a code skeleton with some functions waiting to be implemented and briefly explain what they need to do. Then the students discuss and code in pairs or teams. Then I plan to call on students to share or explain their work and display their work on my screen as they explain so that everyone can see. Then I provide feedback on what they did. The guided practice may take longer than 10 minutes, maybe 15. It depends on what the activity is, but I would say 10 to 15 minutes is probably, 15 minutes is a little long, maybe 10 minutes is good enough. Then independent practice comes after that for about 10 minutes. This is where I assign homework, which is a summative activity, but not an assessment, just an assignment. These could be FRQ questions from the problem bank, or they could be coding exercises that I found online or have access to through a chosen curriculum. Then I plan to give students some time to work on that, like I said, for 10 minutes. And by being available to answer their questions, I can help build trust and help the students feel more supported. When they see that I care about their progress on an individual level even, they would be more likely to raise their hand or approach me if they're having a problem with the content. Of course, asking their classmates and getting help from their teams would probably be their first method of trying to find the answer, but they can also ask me if they're having difficulty individually or collectively. After that is the end of class routine. And in this part, I plan to give an exit ticket, which is an end of lesson brief formative assessment. It's just one quick question that assesses student understanding of the main concept of the day. Ideally, this is a really simple question, easy to solve and easy to check. Then I plan to collect those and check them after class or after school. This will give me a quick sense of how many people really understood the topic, and that information can be used to inform the next day's lesson plan. Here is a possible lesson outline cheat sheet which summarizes the things I've said so far. All the sections are there along with their time limits and what I plan to do in each part. At the bottom there's a note that says for a 90-minute period you can have start, modeling, progress check, modeling, progress check, guided practice, independent practice, and the end of class. Between the modeling and the progress check, the two sets, you can have maybe a 3-minute break to give students a little rest. My conclusion is that the gradual release of responsibility model of teaching transfers the cognitive load from the teacher to the students over the course of the lesson. This is an effective way to teach. This process, along with the formative feedback along the way, helps students meet the learning objective by the end of the lesson. And the use of a coding platform like Coding Rooms or Repl.it could increase student participation in the guided practice segment and would make presenting and displaying their code much easier. Some of my colleagues in the training I attended have recommended their use, and I'm excited to try them out in my lessons. Regarding the distribution of this material, there are many ways to teach AP Computer Science, and I'm just at the start of this journey, but if you found any of the information presented here interesting or useful, please feel free to share it with others. I'm glad to have participated in this week of training, and look forward to working with everyone in the future.